Good.
Awesome. Okay, this is our last week of class. And then next week, I'll get together with you on Monday to talk about the final. And then I'll probably open the final on the first day of finals week. And then maybe close it up the day before the last day of finals week, unless somebody really needs to go further. So I'd like to get things wrapped up so I can get the grading done. But essentially, I'll let you take it whenever you want to take it over finals week. So I'll talk more about that next week. Let's finish up our chapter 7. So last week we started on linear regression, and we were looking at all quantitative variables. So sometimes you have qualitative variables in your data, and you got to be able to handle them. So the idea is to convert them into quantitative variables. So I'm going to show you how to do that so that you can add that into the regression. Let's just talk briefly about what you got to get done this week. So of course, the homework assignment is due Thursday night as usual. And then a quiz, if you could get that done by Friday night for chapter 7. And I'm only quizzing you up to quantitative and qualitative aspects of the chapter. So that's through 7.6. So there's 2 additional sections in that chapter. If you're looking at your book, when you use your book to take the quiz, I'm not testing you or giving you homework on 7.7 or 7.8. So you can skip those, just through 7.6. And then teams 1 and 2, you have cases to do. So I've posted those on SitLearn. They're ready to go. If you need any help or have any questions, just reach out and let me know. Okay, any questions about what you have to do this week? Okay, so like I said, we're going to go up through 7.6. That's it. So that's the last unit of instruction in the book. Don't do 7.7 and 7.8. Skip them. So we're going to be looking at, as like I said, the categorical independent variables and how we treat them in a regression analysis. It's actually pretty cool the way it works. So what we'll do is, if we have a categorical variable, we'll assign it a value of 0 or 1. Okay, so 0 will mean that it's whatever the categorical variable is. So we're going to look at an example where you have electrical and mechanical are the 2 options for the variable. So for electrical, we assign a 1, and for mechanical, we assign a 0. So we're just converting the categorical data into numeric data so that we can actually run the regression. So I'm going to show you how to do that. It's really cool the way that works. And then once you get that sorted out and you've got your categorical variables reorganized, I'll show you how to do that, then you run the regression. I just wanted to remind you, this is your output. You started working with this last week. The key things you're going to be studying is the R-square valued, which is the coefficient of determination. It tells you the strength of your regression. So how much are your independent variables explaining the dependent variable? And this can take a value anywhere from 0 to 1. So this regression right here is pretty strong. We're explaining about 88.3% of the variance. And we have, in this case, we have 3 variables. So miles was a variable, miles driven in this example. Deliveries, number of deliveries, these were both quantitative variables. And then highway was a categorical variable. So the highway was either a congested highway or not congested highway. So we put a 0 for one and a 1 for the other, and we ran it out. So that's what I'm going to show you how to do today, is add these categorical variables. We also, if you remember from last week, we have to look at these p-values and t-stats. So p-value should be, if it's less than your critical less than your level of significance. So like we did last week, you're either going to use 5% or 1%, and I'll always tell you what it is. So in all of these cases, these are less than 5%. So if 5% was your level of significance, you would say that these variables, you can reject the null hypothesis. And when we're talking about regression, what you're trying to look for here is, are these coefficients significantly different from 0? So your null hypothesis is that these coefficients equal 0. So if you can reject that, that means that these coefficients have value, meaning they're good explanatory variables in the regression. So I know it takes a while to get your mind wrapped around that, but in essence, you want to be able to reject the null hypothesis. Right? You want to be able to say that these are decent variables in predicting what we're trying to predict here. Okay. And then there's your confidence intervals, so you can use those too. So this was 95 here, and this was 99. So this would be a 5% level of significance. This would be a 1% level of significance. So that's what your output looks like. We're going to continue with that. I want to take you over and just show you around the class exercise, and then there's only one homework assignment, one question, I should say. Sorry, there's a helicopter flying over my head right now. So there's one problem, but it has a lot of different sections to it. So I'll show you how to do that. So let's go over there. I'm going to pull up my Excel file and show you around. So everybody see the Excel file okay?
Yes, ma'am.
All right, so directions over here in the green tab, same as usual, right? So make sure you save it on your homework tab. So like I said, you only got one this week. So you're gonna save it here, and then make sure you rename it using this convention right here. All right, so just use that convention. All right, I left this up. We looked at this last week, but I left it up because we're gonna be looking at residuals again. So we'll talk about that in a sec. And then this is the in-class problem that's very similar to the homework problem. So let's take a look at this. All right, so data, what we have here is, this is the Y variable, the amount of time, okay? This is the number of months since they did the repair. So this is a repair example. I'll walk you through the example in a second. I just want you to look at these. So this is the amount of months since the repair. This is the type of repair. So notice this is a categorical variable. And you've got two options, either electrical repair or mechanical repair. So we're going to assign a 0 to 1 of these and a 1 to the other one. So in essence, what we're going to do is convert it to a numeric variable. And then notice that you also have another categorical variable here, and this one is the repair person's name. Fortunately, we only have 2 of those as well, so we're going to have a 0 and a 1. I'll talk to you later about how you deal with having more than 2 categorical variables. Just get started with a simple example. All right, so let's read through. We got a filtration company. They provide maintenance service for water filtration systems throughout southern Florida. Customers contact them with requests for maintenance service. To estimate the service time and the service cost, Johnson's managers want to predict the repair time necessary for each maintenance request. So that's what they're trying to predict, is the repair time that it takes to do these repairs. Okay. Hence, repair time in hours is the dependent variable, the Y variable. Repair time is believed to be related to 3 factors. The number of months since the last maintenance service, so you see that as X1, number of months. The type of repair problem, so you see that here as X2. And the repair person who performs the repair. So like I said, we had 2 people, so that's this X3. Data for a sample of 10 service calls are reported below. So first we have to develop a linear regression equation to predict repair time. So that's Y, repair time. given the number of months since the last maintenance service. So we're only going to use X1 in the first regression. So we're going to take this in baby steps and just keep adding more X's until we get to having all of these load in the regression. So if we just start with that first one and we run the regression, let me remind you how to do that. So you go to data. Maybe you go to data. Oh, that's really bizarre. I have not yet had that happen. I just looked at this morning. My little data analysis is completely gone. Strange. I did do an update yesterday. I wonder if that's what happened. Well, anyways, are you folks okay with knowing how to get your data analysis feature to show up?
Yes, ma'am.
All right, so if you don't know how to get it, remember you go to File, and if you're on Windows, I'm on a Mac. Something must have happened yesterday when I did an update. But normally you see the data analysis toolbox, make sure you have that so you can do a regression. If you have any trouble with that, just reach out. Anyways, if you run that, you would put in for your Y variable this data right here. You put in for your X variable just the months for the first one, and that's it. Okay, and you can ask for the residuals. So you ask for this residual output, including the plots. So the residual plots. All right, so this is our first regression. It's not super powerful. We're only getting an R-squared of about 53%. So just over half of this regression is being explained by the number of months since the last repair. And if you look at your coefficients here, you'd use these to develop this equation that you see here. And then you use these to determine whether or not these coefficients are valuable, so statistically significant. And you can see that both of these are less than 5%, or this one is even less than 1, but definitely they're both less than 5%. That's what we're using for a level of significance. Okay, so we're going to say that both of these, we can reject the null hypothesis that these are equal to 0, meaning that these are valuable coefficients. We can use them to help us predict what's going on with the amount of time it takes to do a repair. All right, then we look at these residual plots too. And if you remember, I'm going to show you this again, the residuals, you want them to look very random and equally dispersed around 0. So I've given you the 4 criteria that we look for when we want to study the residual plot. So this one violates equal variances across the data. So you got smaller variances back here, bigger variances here. This one underpredicts the value of the dependent variables for small and large values, and then overpredicts for intermediate values. This one, there's no symmetry around 0. You got more over 0 than you have under in terms of their variance. And then this one, it lacks independence. So every 4th data point is looking like it's roughly the same. So we'd say that that data isn't independent. They're not random. So that's what we're looking for when we study these plots. The only thing that concerns me about this is the variance seemed kind of big back here, and then it seems like it's getting a little smaller out here. But I'm not going to get overly concerned about it because I only have 10 data points. So you really need a lot more data than this to be able to say anything about the plot. But I want you to get used to that. If we were to do 7.7 book to how to fix some of these problems, so we'd say you'd have a quadratic equation, and I don't want to go there. If you take the next class in data analytics, you can get into quadratics. We'll stick with linear regression. All right, so essentially looking at this, I don't see anything that causes me concern. So this equation, I would say, holds up, but it's not super powerful, right? So when you run this out to get an estimate for y, don't be overly attached to it as being highly predictive. It's only predicting about 53% of the variation. So it's probably going to be off quite often, right? Quite often. It's not going to be highly accurate. All right, so the second part of the problem, what they wanted you to do was create these scatter plots. And you have to do this for your homework too. So to do these, I want to go right in here and show you how to do this. When you do a scatter plot and you want different colors to show up for different aspects, it's like giving the scatter plot a third dimension, which is really cool. So you have to set up 2 series in order to be able to do that. And before you set up those series, you got to sort the data. So I put little notes in here to show you how to do that. And when you watch me do the homework video, you'll see how to walk through that process. Okay, so I've got both electrical and mechanical in this scatter graph, so I can see what electrical looks like and I can see what mechanical looks like. And I have months on this axis and repair time on this axis. So that's the Y, and this is the X in the regression. And this is how electrical and mechanical play out. And it certainly seems as though there's a difference between the two. So it makes sense for us to do another regression and include that variable. Okay, and then we have to do the same thing here for the salespeople. Okay, so the same thing on the y-axis, repair time, same thing on the x, months since last service. That's what you did for regression. And now we're looking at the data. So again, what do you got to do? You got to have 2 series, 1 for each person. And you highlight the X and Y values for that person. So in order for you to do that easily, make sure you sort whatever data you're looking at. Make sure you sort this data by whatever you're trying to do for color coding. So right now I have it sorted by electrical and mechanical. If you want to do this graph, that's how you want it to look, just like that. If you want to do this graph by person, Bob versus Donna, and you got to take your data, so take all this data and resort it by person. Okay, so now I've got all the Bob together and all the Donna together. So when you go to do a scatter plot, you're going to pick up Bob and as one of those series. So you're going to pick up these points in the first series, and you'll pick up these points in the second series. And like I said, when you get to the homework, you watch me do it in the video. You'll see how to do that. But it's a cool way to do the scatter plot with a third dimension, right? With something else besides what's on the X and Y axes. So I think that's really useful to do for you to do. You got one of those to do in the homework. All right, so the person data, if I look at that, I'm not convinced that there's a huge difference between the two. We'll have to see what shows up when we run the regression and see how powerful it is, see if it has statistical significance. Because I'm not as sure, given this data, we've got, seems like points are over to the left here for Donna, and points are more to the right for Bob, but I'm not sure how statistically significant it is. It might load on this variable too, right? So we'll see. All right, so over here, this next one that you have to do, that should say X2. Okay, so we have this type variable right here, and that is loading on the type, right, of repair. So I loaded it based on the original data set. Let me go back to that. So I gave a 1 if it was electrical and a 0 if it was mechanical. So you should see 1 0 1 0 1 1 0 0 1 1. Let's go look. Okay, 1 0 1 0 1 1 0 0 1 1. So that's where that comes from, is just coding it based on whatever it is. So I've converted that categorical variable to ones and zeros. And like I said, if you only have two options, that's easy. One gets a 1 and the other one gets a 0. And it doesn't matter which one you give a 1 and which one you give a 0. That just influences the way you interpret the coefficient once you get it. All right, so I did the same thing here. I did a multiple regression this time. So when you go to your regression and you want to do the x variable, make sure you highlight all of that. And again, you'll see me do that in the homework video. So you're going to highlight both those for the x variables. So you have 2. And your regression output, look how much it improved just by adding the type of repair that we did. So now we're explaining about 86% of the regression. That's a huge improvement from this one that just had, right here, just had months since the repair. Now we're sorting it by type of repair, and that makes sense, right? All right, so let's see what our coefficients look like. So this one, your intercept, it's not statistically significant, but it's not important to us because we talked about this last week. It's really just a forced number that shows where that linear line is lining up with the y-axis. So I don't ever worry if my p-value on the intercept isn't significant. That's not a deal killer, right? These I do worry about. Any of the x-axes, so this is x1, x2. This one is less than 1, this one's less than 1. These critical values are greater than 1.96. So we would reject the null hypothesis. And we would say both of these have an impact on the amount of time it takes to do a repair. Okay, so this is increasing the amount of time by roughly 0.4. And this, the type, so one was electrical. So that's saying that electrical takes 1.26 more, I think that was hours, the time was in hours than a mechanical repair. Okay, so that's going to drive the amount of time. It depends on the type of repair. Okay, so putting your equation together, your intercept, I want 4 decimals. Your x variable, 1, x1 for months, and x2 for the type of repair. Okay. So this adds 1.26 if it's an electrical repair. If it's not, if it's a mechanical repair, then you'd enter a 0 for x2 and this whole thing disappears. So that mechanical repair takes less time. It would only be these 2 components. Does that make sense? What do you think about that, being able to add a categorical variable? You guys there?
Yes, ma'am.
So what do you think about that, being able to do that? Does it make sense what I did here?
Yes, ma'am, it does.
All right. So we're going to add the third one in now, the repair person, and see if that makes it even more powerful. Okay, so we got to, okay, here's the person. We're going to do this in baby steps. All right, so we're going to first do it just the person, and then I'm going to have you do another one where we add the type and the person. So we're just going to study the person first. So we have our original y, we have our x1, and then I'm going to call this one x3 for the person. All right, so how do you, somebody tell me, how do you get these 1s and 0s for the person? Let me copy that for a second and take you back here. Put it right there. What did I do? How's Donna being coded?
1,
Yeah, and how's Bob being coded?
0.
Right. All right, so because we only have 2 people, that makes life easy, right? If you have a third one, you don't code the third one. I'll talk to you more about that when you get to the homework videos. Because you do have one categorical variable that has 3 options. It's not hard to deal with it. So I'll talk to you more about that in the videos. All right, so here we go with x3. All right, so if we do add just x3 all by itself, notice that the equation improved from the first one, but it wasn't nearly as big a jump as we got when we added type. So when we added type, we got all the way up in the 80s, right? 86. And higher is better. So as I suspected, when I looked at the scattered graph, it wasn't really going to impact this type. I didn't see as much there that was obvious. And again, I really need more data than 10 points, but I think you get the gist of it. All right, so let's check it out. Here's the loading factors for the regression. These are the p-values that we want to look at, and check it out. When we use person in the equation, neither one of these are significant. Neither one of them are good predictors of time when we load these into the equation. Okay, so this regression right here doesn't have very much power. Okay, and you notice that this is less than 1.96. This is less than 1.96. Okay, this one is significant, but like I said before, this number is really outside of our relevant range. It's just a number that's generated from the linear regression to hook up to the y-axis. We're not going to be working down in that range. We're going to be working within the range of points that we have. So I'm never really concerned about this one. All right, so this regression really kind of stinks, right? It's not that good. All right, so let's move on and try loading all of them. So this is Y, time in. This is months since the last. This is the type, electric or mechanical, and this is the person. And look at the power we get out of that. So this one's looking a lot more, looks like it has a lot more strength. And all of our coefficients here, we got months, we got type, these look significant at the 5% level. This one fails to make it through though. So essentially what it's saying to us is that the person that does the repair in terms of these 2 people that we're looking at doesn't seem to matter that much. Okay, so both of our people are doing the work in about the same amount of time, is what that's saying. So even though this is negative, meaning that Donna takes less time than Bob, because Donna is the 1. So this would load for Donna, and it would be a 0 for Bob, right? It's not significant. So I wouldn't use it in the equation. It's not a significant variable. Okay. Other than that, I think when I did your homework, I have all these write-ups. So I left them in the homework. Let's take a look at your homework file. So you've got to do, this is a cool example, I like it. You've got a lot more data. You got 300 data points, which is awesome. All right, so there's 311 data points. And it's car information. So this is a type of car, a compact, mid-size, large car. This is the engine displacement, fuel type, premium or regular fuel, highway miles to the gallon, right? And you're going to do the same thing like I just walked you through. You're going to do a simple linear regression for just 2 variables, one of them quantitative, the other one quantitative. And then you're going to do a scatter diagram. So this is really cool. You're going to do a scatter diagram for the linear regression you just did over here, just like I showed you. And you're going to have series for the types of cars so you can start to see where those cars line up in that data. All right, it gives you a 3rd dimension. It's awesome. Okay, then I want you to add some categorical variables. So you're doing a more sophisticated regression here, and notice your R-square value. Right. And you got lots of power here. These are all significant variables, just cool. You got residual plots, and I left these in your write-up so you can interpret what that's saying. So I left all that written stuff. All you got to do is run the regressions for me and tidy it up. Okay, then you do a final one that loads every single factor. It's a huge regression. Develop the equation, set up these plots for me, and then you'll have this part will be there for you to help you interpret what's going on. Okay? So that's what you got to do for homework. It's basically the same thing I just showed you, where you've got some categorical variables, some quantitative variables. Okay, so you got 2 quantitative and you got 2 categorical. That's it. That's all you have to do for this week, is get the categorical down. Do you have any questions on that? How to do it? With 1s and 0s? So for homework, all you have to do is create these regressions. I hope I can get mine back. I hope you can get yours. If you can't, for some reason, get your regression, I have no idea what happened to mine. It's usually right here. No idea. So anyways, I'll find it. If you have any trouble finding yours, I just did an update on my software, so I'm assuming that's what happened. Do you have any questions on how to do this?
No, ma'am.
Okay. Let me go back to my PowerPoint deck. So there's your tasks. Teams 1 and 2, how are you feeling? Make sure you start those cases, by tomorrow. Don't wait till Friday to get them going in case you have questions. Just take them a little bit at a time. Okay. That's all I had for you.
Thank you.
Okay. Take care.
You too.
Thank you.
Welcome.